This is TMUA 2016 paper 2, and this is question 9. This question is talking about two triangles, A, B and C, and X, Y and Z, having the same area. So the two triangles have got the same area, and the question asks which of these extra conditions taken independently, so we need to look at each one individually, one at a time, would imply that they are congruent. So congruent meaning the sides are all the same length, or a combination, angle, side angle, etc. Basically, if you orientate them or flip the two triangles, then they will coincide. They will be the same. And of course, if they've got the same area, that's going to be one of the conditions for congruency as well. So let's look at these conditions separately. Part 1 is AB is the same length as XY and BC is the same length as YZ. So 1, let's draw AB, A to B, and then I'll draw XY in the same place, but I'm going to draw BC down here to complete the triangle, and BC I want to be the same length as YZ, and I want the let's call the area D, and I'm going to have an obtuse angle at Y, so rather than the acute one. So this is Z, but I'm trying to say that YZ is the same length as BC, and I'm going to say the areas are the same. So let's say this is alpha and this is beta in here, these two angles. Then the area of the first triangle, D, equals a half, then these lengths here, so it's AB times BC times the sine of the angle between them. But because this is acute, we can say D equals a half XY times YZ times the sine of the angle between them, sine of beta. But there's nothing stopping sine alpha being the same as sine beta, because one's acute and one's obtuse. So there's nothing to stop the areas from being the same. And these are clearly not congruent. So this does not imply, number 1 does not imply. Let's have a look at number 2. Number 2, we've got AB equals XY again, XY. Then we've got an angle ABC equals the angle XYZ, AB. So this angle here, let's call this alpha again, is the same as this angle here, alpha again. And then this is Z. I'm deliberately trying to draw these at different lengths. However, you can see by the same formula that if these angles are the same and one of the sides is the same, to get the same area, these other two sides will have to be the same. There is absolutely no other way around it by using the formula for the area of a triangle. So these, even though they're not particularly well drawn, have to be congruent. So that's a tick there. And then part C, it talks about the angle ABC being the same as the angle XYZ. So let's just try and draw this again. So what have we got? We've got number 3 now. And we want to think about the angle ABC. So A to B to C, A to B. This angle here, ABC, alpha, C. must be the same as XYZ. So this is the same as this angle up here. So the Y angle here is also alpha. And then it says BCA, so this time this is going to be beta in here, is the same as the angle here at Z, X, Y, Z. So these two angles are the same. Well, if you've got two angles the same in a triangle, the third angle must also be the same because they all need to add up to 180. And we've got two similar triangles, and they're similar because they've got the same angle. However, they're not just similar. Because they've got the same area, they must be congruent. So therefore that condition must hold too. That implies, so condition 3 implies congruent triangles. So of the list of 3 things, we've got no, yes, yes. So condition 1, no, so that's the first 4. Then condition 2 is yes, which is one of these two. And finally condition 3 is yes, which is this one. So the answer is D.